Hi guys, here's the memo explanation for exercise 13.2. Alright, so I asked you to do number 1, 2, and 3. This is number 1. Okay, so for this one, you'll have to classify the shape before you can tell me what x is. So, okay, what do we know? We know that the line AD, so the red lines are equal to each other, and then the purple lines are equal to each other, so the opposite sides are equal. That means if the opposite sides are equal, either it's going to be a rectangle or parallelogram. Okay, obviously if all of them were equal, it would have been a square or a rhombus, but only the opposite sides are equal. Then the other thing that they give me is that this side, this purple side here has 5, the red part is 12, and then this green line is 13. If I do Pythagoras in that triangle, and Pythagoras works, so the short side squared plus the short side squared is equal to the longest side squared, that means that it must be a right angle triangle because Pythagoras only works in right angle triangles. So that's what I'm going to do. I'm going to say, all right, AB squared plus AD squared is equal to DB squared, Pythag. If I substitute those values in, so 5 squared plus 12 squared is equal to 13 squared, I'm going to find that the left-hand side is equal to 169 and the right-hand side is equal to 169, which means that Pythagoras does work, which means that that triangle has to be a right-angled triangle. Okay, so that narrows it down. So now it has to be a rectangle because a rectangle has angles of 90 degrees. Okay, so x is equal to 90 degrees since Pythagoras works. There's two pairs of opposite sides equal. There's an angle of 90 degrees. That means that the classification means that ABCD is a rectangle. All right, number 2. Number 2 looked like this. So they asked you to first work out x and y, and then from there classify the quadrilateral EFGH. Okay, I'm going to start in that green triangle. I know that the angles of a triangle add up to 180, so if I say that plus that plus that equals 180, I should be able to work out x. Okay, so I'm going to start with doing my statement and reason column. There's my 3 angles being added together to give me 180 degrees. There's my reason angles in a triangle. Okay, from there I can solve, so I'm going to say 3x plus 8x plus 2x. That will give me 13x, and then I've just taken that negative 15 over the equal sign and added it to the 180. Okay, from there I get 13x is equal to 195, and I can solve for x by dividing through by 13 to get x alone, which will give me 15 degrees. Okay, I'm going to move to my red triangle, which is there. So again, in my red triangle, I can solve for y using angles in a triangle. Angles in a triangle add up to 180, so 2y plus 25 plus 3y plus 5 all equals 180 degrees, angles in a triangle. Okay, if I get my like terms here together, I'm going to get 6y is equal to 180 minus 25 minus 5, which is 150 degrees. Divide through by 6 to get your y alone, and you're going to find that y is equal to 25. Alright, so now comes the classification step. So the way that a classification step works is that I need to classify the quadrilateral according to the angles that it has. Okay, so in this case here, if you have a look at f is 3y plus 5. So I need to figure out, well, what is that actual angle? So it's going to be 3 times 25 plus 5. And I'm going to do that for every single angle. Okay, so for E, this is the angle for E. It's this whole angle, 2y plus 3x minus 15. So if I substitute the values that I found for x and y in there, I'm going to find that E is equal to 80. I'm going to do the same thing for f and substitute my y as 25. I'm going to find f is also equal to 80 degrees. For g, I do the same thing and I find it's equal to also 80 degrees. And then if I solve for h, I find that h is equal to 120. Okay, I can double check myself here by saying, well, do all of these add up to 360 because quadrilateral angles add up to 360, and they do. If I want to make a quick sketch for myself, so sometimes it's difficult to just look at the angles and just figure out what type of quadrilateral it is, but it helps to draw a sketch. Okay, so if I do a rough sketch of what I'm looking at, that's what it looks like. Okay, so there's my 3 angles of 80. There's one bigger angle that's 120 degrees, and you can see quite clearly from the sketch that you're working with a kite, but the reason it's a kite is because you've got one pair of opposite angles that are equal. Okay, so EFG's H is a kite. Alright, let's go on to number 3. Number 3 looked like this. Again, you needed to solve for x and then classify. So I'm just going to use angles in a quad add up to 360. So I'm going to basically just say this. X plus 2x plus this angle here, 3x minus 60 plus 60 should equal 360 because it's a quadrilateral. It's got 4 sides. From there, I can solve. Okay, so x plus 2x plus 3x, that will give me 6x. I've taken the negative 60 over and added it, and I've taken the positive 60 over and subtracted it, which still gives me 360. And then from there, I can find that x is equal to 60 degrees. Okay, now I'm going to start classifying, so I'm going to figure out the different sizes of my angles. Alright, for I can substitute x is equal to 60 degrees because I worked that out, and I find that the angle I is equal to 120. J is equal to 2 times 60, which is also 120. Let's see here, K is just equal to X, so K is just equal to 60. And then L, they've already told me, is equal to 60. Okay, so I've got 2 angles that are equal to 120 and 2 angles that are equal to 60. If they were opposite each other, I would say that it's probably a parallelogram, but they're not opposite each other, they're next to each other. So if I draw a sketch of what it looks like that. Okay, so they're next to each other, and I can clearly see that that it forms a trapezium. Okay, so 2 pairs of adjacent angles equal, 2 pairs of angles that are next to each other equal. That means that IJKL is a trapezium. Alright guys, hope that helped.